So good afternoon. My name is Tim Vale, and welcome again to another episode of Big Ideas in App Architecture. I am thrilled today to be joined by Joe Lynch, who has a long and distinguished career in software development, engineering, infrastructure, all sorts of experiences and technologies. I'm really excited to talk to Joe today. I think we're going to learn a lot about his philosophy, not on just building teams, but technology in general. So Joe, welcome to the show. Very glad to have you here.
Thanks, Tim. Appreciate it. Thanks for the kind words.
Hey, that's what I'm here to do. When we do these episodes, one of the things that always fascinates me is just spending a little bit of time, getting to know you, the audience getting to know you, your background. For me, when I was first starting out of college, I don't think if you had told me then, that 20, 30 some odd years out, I'd be writing software for a living, doing all these things. I don't think I would believe you. I think I had in my mind, I was going to be some very different thing. So I'm always curious, when we start these episodes, to understand a little bit about kind of how you got to where you are today. What's been the journey for you thus far? But I think almost more interestingly, what inspired you to kind of go down this path? And is it the path that, maybe like me, you didn't quite expect, or was it the path you expected? So maybe just start us off by a little story of Joe here.
Sure. Yeah, I come from a long line of distributed systems engineers. I grew up in the Philadelphia area. Have lived here all my life. I still live in the Philadelphia area, and I think the biggest thing, the thing that drove me to building systems in the long term, is solving problems. I like to solve problems, and I think I figured out that I'm pretty bad at solving problems in the physical world. So I remember I would try to make little boats and things that would float, and they were really, really bad. But somehow I must have figured out that in the virtual world where things aren't, governed by as many laws, and maybe I would get better at it. But truthfully, when I think back, I remember when I applied to college, I went to the University of Pennsylvania. I remember I had to check off the Wharton School or something else. And the something else for me, the only other thing I could think of was physics, because I liked physics class, oddly enough, because I didn't particularly like math. Wasn't particularly good at it, but it was just a tool that you had to use to solve problems in physics. And I happened to like I happened to enjoy physics for some reason. So I thought for all of 30 seconds and checked physics and sent the thing. And I didn't realize my life how different would my life be if I majored in, finance at the Wharton School or something. It could be materially different. So, anyway, I thought I was going to be a physicist. I graduated with a degree in physics. I started at a PhD program, and I'm ashamed to admit that I left pretty fast. But I wanted the elbow patches. I wanted the pipe. I wanted the PhD on the wall, but I didn't want to earn the PhD. And it's the earning part that I think is pretty important. So I went into technology in the year 2000, during the .bomb time. And at that time, it was, if you had a degree in something semi-analytical and you didn't know what to do, you went into consulting. And so that's what I did. My mom used to ask me, what am I consulting on? And, what is consulting? And I explained to her, you borrow somebody's watch to tell them the time and charge them $250 an hour to do it. So that's what consulting was. Now, so in college, I actually did some programming in C for physics labs and stuff. And I had a job where I wrote some software that tested a lot of circuit boards and stuff that had to do with the proving whether neutrinos have mass, these particles that are important in high energy physics. And then in high school, I took Pascal. Those are the only connections to computer science that I had, or programming that I had. But I never thought for a second I would build software for a living. So I went to this consulting firm. It turned out that they valued people with my kind of background. Most of the people that I worked with were actually physics PhDs and math PhDs and stuff like that. And they put them to work solving business problems. And I got to work with great people and learn how to build systems. And the thing that was great, which I realize in hindsight is not all that common, is I got to own things end to end. And, in the beginning, I knew nothing. By the time I left, I was there 10 years. I had to sell my own work. I had my own practice area. But my SDLC, if you will, started with a cup of coffee with a VP trying to understand their business problems. It wasn't like, where are the requirements, or somebody send me the requirement stock or something. That's not a world I've ever lived in. So I'm glad for that. I left after 10 years because I had a growing family and I needed to get off the road. And then I went to a company within the logistics space and managed an engineering organization there. They're a company you wouldn't have ever heard of, but if you look around your room, chances are 60% or 70% of the stuff you have, this company was important in making sure that it came into the country. And then I went to a tech startup, Series A to Series B, largely within the I guess you'd call it the ad tech vein. Great people. I got to work with data at a new scale that was, new to me, distributed system. Like I went past enterprise scale and went to, for lack of a better term, I'll call it internet scale, and had to learn a lot about distributed systems, which I really enjoyed. And then I felt like after a while, I felt like I wasn't really growing, or I hadn't had that feeling where I was having trouble keeping up. Like I wanted to have that feeling again. I felt like I was spending too much time at the whiteboard talking and not enough scribbling on the notepad listening. So I wanted to go to a place where I would have trouble keeping up. And if having trouble keeping up is the definition of success, I was pretty successful at Google. So I was there about 5.5 years. First couple of years I was in storage. I managed the storage efficiency org. So this was the org that was responsible for, through engineering approaches, whether planning or making changes to systems, figuring out ways to save Google money on its massive storage spend. And the thing that was neat about it was I got to work with all these people that are, in hindsight, they're the people that wrote the papers on, Google file system and Spanner and Bigtable and all this. And it was a great learning experience. I didn't have their expertise, and I didn't. I learned enough to be dangerous, but I didn't. I wasn't able to match that expertise, but I got to learn a lot. So the thing that was great was working with people across all the business lines, because everybody has data to store: ads, search, cloud, photos, whoever you could imagine, YouTube, and also learning a lot about their storage systems and databases, and working with some great people. And I remember the tech lead on the team, he said something like, "I don't get out of bed for less than an exabyte." Hundreds of petabytes was like a rounding error in terms of the places that we focus. It was a lot of fun. And then I worked in capacity planning, building a system that produces the capacity plans that underlie Google Cloud's products. And then the last few years, I worked on the observability platform. I was responsible for the data ingestion, for logs, metrics, all the things that you need to manage your systems at scale. And then I spent a year at Twilio, where I was responsible for infrastructure, so compute, databases, observability, cost efficiency, networking, et cetera. And that brings me to today. So, I fell ass backwards into technology is the bottom line. But I feel fortunate to have met a lot of great people and learned a few things along the way.
No, I think I love your background. It's eerily similar in many ways to my own. Particularly kind of your last comment there. I don't think I ever thought I would be doing what I'm doing today. I was very curious. I like to take things apart and put them back together. I loved physics also in college, or not in college, in high school. Ended up really, really enjoying math in college, did a lot of advanced math stuff, but thought I was going to be, I don't know exactly what I thought I was going to be, but I had a finance degree and started interviewing with a bunch of banks at like entry-level banking positions and stuff like that. I thought, what the heck is this? This is not for me. So went back and dual majored, and that really is what I think charted the new course. I dual majored in MIS, and then went into consulting like you did, and kind of the rest is history. And started.
What firm did you work at?
Ernst & Young.
Okay.
My first job. And funny story about that, by the way, it was it was in the early or late 90s, kind of right around the time you were doing consulting. And I remember distinctly, they said, hey, welcome. You're going to start on this date. We recommend you go out and buy 3 suits because, we're what a business formal. I don't even know what you called it back then. But so I did. I dutifully went out and bought a gray suit, a navy suit, and a black suit. I think I wore navy the first day. I literally think day 2, or certainly within the first week, they sent a letter saying we've moved to business casual. And so those suits sat in my closet for years as a reminder of my first job at Ernst & Young, never really to be worn again.
I was going to say the CEO at the consulting firm where I worked, which is a much smaller firm, he was old school. We wore ties for the whole time I was there till 2010. I left in 2010. We had ties every day.
I do think about that now. I mean, obviously, I'm at home, you're at home, we're working from home. It's sometimes a leap or a stretch just to think about going back into the office. But
yeah,
boy, can you imagine going into an office, 5 days a week now, wearing a suit and tie? It just seems
not anymore.
So fun. Can you imagine starting a team right now, building a team of engineers, saying, "Hey, listen, we'd like you to come into the office every day, and we'd like you to wear a suit and tie."
Yeah.
I don't think we'd get as many people as
yeah, I agree.
So, when you and I talked prior to the show, one of the things I found so interesting, not only about the background and the story you shared, but it's just some of your kind of philosophical approaches to, I think, building software, designing software. I thought maybe we'd spend a little time just talking about some of those key ideas. I think a little bit like you, I came to a lot of the lessons I learned, just by working out problems that I had or the teams that I worked with had. I know you've got a lot of like kind of really strong ideas about things. I thought maybe we just kind of jump into a couple of those ideas and see where the conversation leads. But I thought your philosophy, a lot of your ideas just around problem solving, all the stuff that goes into building software was really fascinating to me. So maybe we just take one of those and see where the conversation leads.
Sure. I think I have a habit of while doing something like designing software or participating in the process of designing software, I sort of like take an approach where I'm trying to figure out like the patterns within there that are unrelated to the software that you're designing, like the process behind the process in a sense. And so I suppose a lot of the observations that I make are they're meta in that sense, for lack of a better term. And all the things that are useful are not original, and all the ones that are original are not particularly useful. So I'll try to, So I'll try to talk about the ones that by definition, I've learned from other people and places. They say that a smart person learns from their own mistakes. A wise person learns from those of others. I'm certainly not wise, and it's a stretch to say that I'm smart because I have to trip over the same stone 3, 4, 5 times before I learn. And the definition of insanity is to try the same thing over and over and expect different results. So I a lot of times I found myself in that situation. But I do tend to get interested in these, like, for lack of a better term, I'll call them principles. So you have, like, the solid principles, and you have Conway's law and Demeter's law, and design patterns and all these things. I tend to find them interesting, but I have come up with one that I think that's important, that I keep in mind because of the fact that I enjoy this stuff, and I call it the the grand unified theory of software engineering. So Einstein pursued the grand unified theory for the rest of his life after he figured out general relativity, and he died, unable to do it. But I've figured out the grand unified theory of software engineering. Do you want to know what it is?
I do. Some say you are the Einstein of software engineering.
Absolutely, absolutely. Yeah, it's been said. So I think that the single law in software engineering is that aside from math and physics, there are no laws in software engineering. That's it. And if you think you've found, if you think you've found a law, read this one again. So like like when I think back about all the things that I've learned, like Conway's law is not a law, right? It's like a law is something that's generally speaking inviolable. It's not a law. It's a tendency, right?
What is I should know this, and I'm embarrassed to admit that I don't. But what is Conway's law?
It just says that the software that you build will tend to reflect the communication structure of your organization. And so, if you have, let's say you've got 9 sub teams working on a compiler, you'll build a 9-pass compiler. And so, that's a toy example, right? But one of the ways that you can see it in reality is you can see companies that build certain software, and all of a sudden their website starts to reflect like their department structure, or their department structure starts to align with the way they think about their modules. And another one that I think is more sort of obvious is that if you so I worked at Google, and they had this small independent teams concept, which is not novel, right? Other companies like Amazon do it, but Google does it in a very specific way. And within that team, nobody can tell you what to do. Like the tech lead on that team is the chief. Like if Sundar wants to get something done, he's got to ask a few favors to have. There's no such thing as command and control when it comes to the sanctity of that team. And they run independently. They will tend not to coordinate with other teams if they can avoid it. And they have very well defined services, and services generally don't go out, never span a team. And then they only communicate with other teams in terms of meaningful messages via quarterly OKRs. That's how you can get a commitment from one team to another. This sounds like microservices, right? Like, and so
it does.
Yeah. Well, so and what it's basically saying is, because of the fact that this organizational structure was in place, you've created a very strong incentive for the software to look a certain way. And so sometimes what people will do is say, all right, well, let me decide how I want my software to look. And I will do reverse Conway's law, which is I'll make the org structure and communication structure that will incentivize that software architecture. So I was just picking that out as an example.
Yeah, that's actually super fascinating. I mean, I'm thinking, I had not heard that, but boy, it resonates. I mean, I had not heard that law described or wasn't familiar with it, but that is something that I have seen play out many times.
It's funny because you think you're, no, that won't happen to us. But before you know it, it kind of happens. But it's not a literal law, right? It's not like F equals MA or something. And so my joke about my grand unified theory is just like that. I don't think there is a grand unified theory except for literally like math and, speed of light. Like there are a couple of things that are just givens, and that one more, which is it's harder to get, trying to get a date out of a software engineer is like trying to get blood out of a stone. That's the only other one that I've noticed as well, but everything else is up for grabs.
Yeah, I do think you're right. I mean, there are, just in the many years I've been writing software, you reflect back on kind of the things that were, let me use the term taken as gospel, but taken as law, whether it was design patterns or just kind of ways of doing things that, like, if you weren't doing them, it's like you almost didn't, you weren't part of the club. You weren't
you were a sinner.
You were a sinner.
Yeah.
Sinner.
Yeah.
Get out. And you're right. Those have changed a lot over the years, and I think actually it's a pretty astute observation, because I think when you look back over time and you realize that, almost every couple years, there's some new thing that everybody's doing that will ultimately fall out of favor to be replaced by something else. I mean, I think it is actually, when you come across those things that people are raging or raving about now, you take a step back, you think this is probably something that a couple of years from now people will have moved on from.
Yeah. You're getting into a nuance, it's related, which is going a little further, which is kind of like the no silver bullet thing. I think it was Brooks, the guy that wrote the Mythical Man Month, who wrote the no silver bullet essay or whatever, which basically takes the position that, like, you may think you have found it, but there's no one thing that's going to affect the efficiency or effectiveness of building software by even an order of magnitude. You may think you have found it, but you haven't. Object-oriented programming, functional programming, actors, microservices, enterprise service buses, probably ChatGPT, though I'm not informed enough to that one's a little wilder, I'll say. But so far that's turned out to be true. Now when I say that there are no laws, my only point there is that there aren't absolutes. I do actually think there are very, very useful principles that you can hold on to as heuristics and apply intelligently. But I just try to, because I get excited about them, I try to be mindful of the fact that they're just that, they're heuristics. And so you take something, and sometimes what I find is a heuristic can be both a useful decision-making shortcut, and it can also be a bias. It depends on context. So there was, people used to say, nobody ever got fired for choosing IBM. Right? It's like, hey, when in doubt, choose, the sort of leading vendor for something. And it was almost also like halfway a joke about the incompetence of, say, some, technical leader somewhere who didn't know what they were doing. But I found myself using it recently, where we were building a Kubernetes platform at a company where I worked. And the team wanted to revisit every single decision. We had to figure out, what kind of container registry do we want? And I found myself saying, nobody got fired for choosing IBM. Like, use Amazon's managed container registry. Like, for every single thing, use commodity options so that we can boil down to those problems that are distinctive for us. 6 months from now, you are not going to be thinking about, oh man, I chose the wrong container registry. You're going to be thinking about, oh, I should have made the developer experience easier to adopt this platform. So that's an example of where, like, I'm using it there almost as a decision-making aid, when most of the time you'll tend to use it as, like, almost mocking the simplicity of some people's decisions. And I find, like, a lot of principles sort of work that way.
Yeah, I mean, I'd love to hear more of them, because I again, just it resonates so strongly. And I think one thing that I've observed a lot lately, there's some similarities and some differences, but I have found myself saying this in coaching people on, is like, don't let perfect be the enemy of good.
Absolutely. Absolutely.
And that description of, like, searching for the best, artifact repositories is a little bit like that. You spend so much time poring over all of these details, which in the grand scheme of things turn out to be inconsequential. You take your eye off of the big picture. But why? Because, there's so much pressure on IT teams. There's so much pressure on us as leaders, software developers, companies, to get everything right. I mean, the stakes seem so high. I think there's this pressure to be right about everything. Did you do your due diligence? Did you analyze every option for this thing, no matter how small it may seem to be at the time? I just think people feel like they owe it, to someone or something to do these things. But yeah, what ends up happening is we just waste so much time, poring over this minutia that we lose, oftentimes the bigger picture.
Yeah. I know exactly what you mean. And I think we all do it, because I think I don't think we're set up well for learning how to solve problems in a land where so many things are probabilistic. We learn in this environment with deterministic problems. You think about grade school, high school, college. They give you a problem definition. That problem definition is perfectly specified. There's no ambiguity, and there's with the exception of, say, maybe taking, like when I say problem, I'll talk about, say, math, physics, chemistry, things like that. I'm not talking about like an essay or something where you can take different positions. But the problem is fixed, and then you just focus on the solution. And your job is, there's only one way to do it usually, or I have certain well-defined outcomes that I have to achieve in that solution. So you got to have the best solution. And that's what we're taught. And what I find is that very, very few business problems or technical problems are framed that way. Most of the time, your first problem is defining the problem. And my experience is that we often go from, if you think about it logically, the steps that we might take when we're designing software, we start with there's the background, the real stuff that you can describe, the phenomena, if you will, the stimulus for getting you to think about it. Then you form some problem definition. Then you say, okay, I've got that problem. Now let me create a solution space. Maybe I've got 5 different ways to solve it. Then I go and I zero in on the one that I think is best, and then I design the hell out of that one. And only at the end of that process do most people start to get peer review, presuming for a second that the problem is large enough to merit peer review. I mean, not every problem is. But what happens, I find, is if you watch people that are just really blunt on design docs, those people, right? There's some people that are always like, oh, looks great. And then there's other people that just tear design docs apart. And if you watch them, there's often like when people are giving meaningful comments, they often come in approximately 2 flavors. One is they're like, yeah, that's right, but don't forget to update the XYZ while you're in there. And, oh yeah, and remember, we got to use the new RBAC framework over here. Those are like sort of aiding the general discussion. And then you'll have people that are like, but why are you doing it this way? And like, they don't say exactly that, but that's what they're fighting, the fundamental of what the design doc is trying to do. And if you look back, if you unwind it, oftentimes it's a problem. They're indirectly pointing out a problem with like the framing, or a problem with the analysis where they've chosen which path to do. Given the fact that, for a framing and that they chose path 3, they're like, yeah, this is a reasonable design for path 3. But I kind of think you should have chosen path 2, or I think you have the problem framed wrong. But we often don't talk about these things. We often don't even use the term. We talk about solution space a lot. How often do we hear the term problem space? Like I usually try to, when it's a tough one anyway, when it's non-trivial, I usually encourage people to like think about the problem space. But it's a space because there's a lot of different ways to define a problem. There was a really good book that I read, and because I'm going to diss it in a small way, I won't name the book, because otherwise it was actually a really, really good book. And one of the things it was good at was it talked a lot about how you can apply design, basic design principles to project structure. And it was very well thought out. But they were using this one example that was a literal example that they did, and they were defending it as like this was this great example. And in the beginning, they're like the requirements, and like we gathered the requirements, and the requirements were we need to build the most generic infrastructure that will allow us to be infinitely flexible. Does that sound like what a business person would say? No, that's like, that's an engineer's confirmation bias at work, which is, we always need a generic framework that's going to do X, Y, Z. And so I don't know. I think you often have to inventory the problem space and then, go with the right best problem definition, and then inventory the solution space. And sometimes you need to do, for lack of a better term, what I would call a comparative analysis of options and get people to buy into, we're going to choose option 3 and here's why. Then design option 3. I don't mean to suggest that it has to be this mechanical thing, but that sometimes the disconnect is way back in the problem definition or in the analysis.
It's really fascinating because, again, I think, I've tended to see this a lot, and we tend to see this, I think, sometimes with the customers that we interact with or the prospects that we interact with, because, and maybe I'm thinking about it a little bit differently or taking in a slightly different direction, but I think if there hasn't been true collaboration on defining the problem, right, the problem space, and you allow a group of people to kind of move very quickly down into solutioning, right, and then you get there, right, and that's when you bring in a broader team to say, hey, what do you think, right? Boy, it's really hard to pull people back from the investment of time they made in coming up with a solution. They become very emotionally attached to their ideas, things that they've done, right? And so, it becomes, especially if the concern isn't around the solution, but way back before the solution was created in the problem space, just winding people back. I mean, I've been in countless meetings where people just it's human nature. Unfortunately, it's not that they're bad people to be defensive. Well, what do you mean? This isn't the ideal solution. Well, and it becomes very difficult. So I think I really like this idea of like focusing in on the problem. Let's get that right. Let's make sure we get that right before we move into the solution, because once we've committed and kind of gone down this solutioning path, it's really hard for people to accept kind of a rewind on that.
Yeah,
human nature is just, it's tough.
Yeah, think about going even further. You sometimes you stumble on what are conception problems at code review time.
Oh yeah,
right? It's even worse.
Definitely.
Right?
Definitely.
They're like 13 steps before there was a misconception. I think it was Rich Hickey is probably one of my favorite thinkers. I don't know if you've ever listened to any of his stuff, but if not, definitely watch Simple Made Easy. It's probably the best for me anyway. It was the most interesting. It's sort of like meta, I guess, similar to this discussion. Is the most interesting tech talk that I've ever seen. Is Simple Made Easy. But anyway, yeah, he talks about a lot of this kind of stuff. But there's the thing that's very real is people dispute the actual math due to the research anymore. But Barry Boehm, who was one of the I don't know, if not the most prominent, one of the most prominent software researchers to ever live, coined this idea of the cone of uncertainty, where you start out with you start out with so much uncertainty as far as what you're trying to do. And, you explore, you design, you develop it, you get it out there, you move it. Before you know it, only at that time does it really start to come together, right? And he makes the point that, which is obvious, the cheapest time to fix something is way back here. And but he actually did research to show like the math of how much more expensive it is to fix something when you've got a misconception in production versus when it's just at the whiteboard. I mean, the numbers are enormous.
Well, and two things come to mind on that. One is, this idea of OKRs. The connection here is, maybe a little bit tenuous, but what I have found is that like we get OKRs can be great, but they do define these touch points between organizations, right? And sometimes, as you were describing, they may be the only thing that's really holding these two organizations together, right? I'm gonna have this shared OKR that makes this one thing.
Yeah, you put them on a message bus and and you get an ACK from the team.
And what I've found sometimes is that this problem that we've just been discussing, though, kind of finds its way into that. Like, there's been all of this thinking about a problem, all of this designing a solution, getting to the point where the solution is almost ready. And it's at that point, and at that point only, that we say, let me share it cross-functionally. Let me share it with this other group because this OKR said that I should or did.
Yeah.
And to your point, at that point, it's so late in the game. Like, the idea isn't to necessarily share the finished product and get input. When you're building and trying to solve really complex problems and building complex software, just as you said, you don't want to put all this time and effort to design and all, become so deeply emotionally vested, share it so late that it's like, well, wait a minute, this isn't anywhere near what we wanted. And now we've got to go right back to the beginning. And I think sometimes these silos in organizations, that kind of create this environment where I'm only going to show you something when I think it's done and ready. I don't know about that.
Yeah, and I think there are legitimate reasons why that happens. Like you said, due to human nature. And if there's one other thing that I think about often, it's humans build software. Software.
At least for now.
Yeah,
At least for now.
Wait till Chat GPT 6.
Yeah, that's right.
And so what that means is, like, all the vulnerabilities that we have as humans, think about how you communicate with your sibling or your wife or your cousin or whatever, somebody where every relationship you have is imperfect. Even somebody that you know really well, there's disconnects all the time. And we are, in that sense, a capital S system in like the systems theory sense. Well, imagine the complexity of the system of getting a team of just a single team of 7 to work together. And then an organization of, cockroach, 150 engineers or something, doing something as complicated as what you're doing. It's a challenge. And so this is not intended to be a green unified theory, but I have found an approach that I think tends to work well at the, or maybe it's just because it's flexible and is resilient, but for getting through that validation process. And I call it concentric circle validation. Not that this is, and it's not novel, but there's and part of it might also be catered to the way that I am. It might not be the right, so for example, if you talk to people, they're like, whoa, we got to get the right people together. Let's set up a conference call with 8 people. Oh my gosh. I don't want to start like exploration of solving a problem with 8 people. I don't assume that that's actually a good way to go about it. So usually I would prefer that there's one person. First off, you have to define a lead. That lead has full decision-making authority within that space, unless there happens, and there might be like tech leads that can technically overrule them, but more or less they're just there to support them. But if somebody's going to own a design that within that space, they have the ability to make technical decisions where it's very clear who above them does, but there's crystal clear decision-making authority. Usually what I personally, if I'm doing it, I need to sort of scribble on a notepad, think about it, sleep on it, not take a long time. And well, in fact, Rich Hickey has another talk called Hammock Driven Development, where he talks about this. He promotes laying around in your hammock, thinking about this. But anyway, personally, I find I have to noodle on it, And then what I do is I have my 1 or 2 trusted design partners, and I've only figured out through experience, there are a couple of people where we have close enough values where we sort of groove in, communication wise, and we can feed off one another and communicate in something of a shorthand. So it's not so much that because I have these 2 people that these other two people aren't great. It's just somehow there's a strong connection there. It's a little hard to describe, but I think you know what I mean. So they're your go-to people. You explore with them. Okay, now it's, it makes sense at the whiteboard. Meanwhile, personally, I haven't written anything down yet necessarily. Some people will say that that's bad. But the first thing I want to fail fast. And writing something down for me is not the fastest way to fail. Like, I want to disprove the approach in a sense. And so I'll show it to people, have them beat up on it. And then start to, basically it's like, that's my level 1 review. And then I go out to level 2. And that's what I mean by like concentric circle. And they have to be small chunks of people, not big chunks of people. So it's like, okay, I've got my level 1 peer group. Now I want to bring in my level 2 ones. There's the ones that are like the really tougher tech leads who understand the related modules, and they're going to tear it to shit. But I know that if it gets through them, it's solid. And then after that, it's like, okay, now it's for broader consumption. I'll take your comments, but frankly, unless you find a fundamental flaw, it's getting pretty baked, and like going down a process like that, it's almost like getting a bill through Congress, I suspect, just tiny little bits, getting 1 or 2 people on board and then gradually working out.
No, I think it makes a ton of sense. It strikes me as a very efficient way because you put these ideas in front of large groups, everybody kind of at different levels of influence, different levels of knowledge. It can become, and I've seen this play out again so many times with these meetings where you're just hoping to get, a little bit of feedback turned just into, the wild, wild west. Because it's not well controlled, not well organized ultimately.
Yeah. And ultimately you're trying, when you're trying to deliver business value, not software, when you're focused on building software. And you should be optimizing for time to value, right? And there are a lot of ways that you can do that. Obviously I could type faster, but that's not, putting aside again ChatGPT or typing faster. Those aren't like the best. Those aren't the best ways to minimize mean time to value. It's to reduce your queues, your dead time, right? And those queues, some of the biggest ones are, oh, I wrote this document, but I got to get on the calendar with the product manager and they're out for 4 days. And then when they get back, they've got, I'm not picking on product, I'm just making something up. Then they got to dig out of their email so that, there's another couple of days. Well, now I've created waste because I've paged this out of my head. I don't remember what I was thinking anymore. Now I got to page it back in. Then the product manager gives me feedback and I realize I was off base in some way. I go back, do stuff. Then I got to get on their calendar again, right? Then I'm overly expansive in who I ask to review my design because I don't want to hurt anybody's feelings, right? The issue is efficiency and inclusiveness are at odds sometimes. And I don't want everybody's vote on everything, including my own. If I want to know what kind of pizza we're ordering, that's a fully democratic decision. But if we're going to, decide, how we're going to build module XYZ, there's a small set of subject matter experts that I want to weigh in. And ideally that's it. And I don't want everybody to comment on it because it's inefficient and it'll cause that queuing and you'll never deliver the value.
So Joe, I know we're kind of coming up on the time we had allotted. Honestly, I think you and I could probably talk about a whole host of other things for much, much longer. So maybe what we'll do, maybe we'll just call this part 1 of the Joe Lynch Grand Unified Theory series. So stay tuned for part 2.
Please don't put that title out as clickbait. It's obviously sarcastic.
part 1 of the Joe Lynch Grand Unified Theory coming to you live. So maybe we close up on this because the truth of it is I think this has been a fascinating, set of insights and would love to keep talking with you about them. But, as we've ended maybe a handful of other podcasts on just kind of, a little bit of looking forward, I'm curious, given how well read you are, how thoughtful you are in so many of these things, are there things, in the industry, technology, anything right now that's kind of catching your eye as like, hey, this is something, that I'm going to I'm personally interested and want to spend a lot of time researching, looking at, paying attention. I'm just kind of curious what's caught your attention over the last 6 months. Where are you going to be focusing some of your time and energy, you think?
Yeah, there are a few things. One of them is, frankly, directly related to CockroachDB. That's why I communicate with you guys. I think you're the best at what you do. I think you're out in front leading, and you're trying to simplify the overall experience of developing high availability services. This is like a really, really big deal. I think a lot of people aren't caught up to it yet, in my opinion, because the new SQL database is not yet a household primitive. It's not yet commoditized. And I think commoditized is not the right, it's not yet normalized. It's kind of like, people heard about the spanner thing, and it's like that's whiz bang and rocket ships, and you have to be on Google to use that. And then there are other ones that are coming along, and hey, I hear about CockroachDB and Yugabyte and things like that. But I think to be a household tool that any architect at any company will bring out is AWS has to come out with a competing product. And as soon as they do that, I mean, it's only a matter of time. It's even, there's even references to it online to them working on it, right? As soon as that happens and people start to get a sense that they can get all the guarantees of a traditional relational database while still having high availability and horizontal scalability and all the things you couldn't have before, I think it's great. It's going to simplify people's lives. And the thing is that we need this in order to be effective in developing software. Things are getting more complicated, not less. And all the things that you have to understand in order to build an effective system these days, it's sort of mind-blowing. And something like CockroachDB in the way that you can be declarative about distributing the data and things like that, it's a huge deal as far as I'm concerned. It should be. I think it'll change the game. I think it'll take away a lot of the workloads from NoSQL databases, not all of them, but a lot of them. And then I think that a lot of CIOs who are used to having conversations like, how much downtime can you afford? They won't have to have that conversation anymore. A lot of, the play for these databases has often been like scale, and people say, I don't need that. I am not at Google scale. Sure. But do you want to go to your head of operations and beg for downtime? Like, no CIO in their right mind would want to do that. Well, what if high availability just sort of came for free? I think that could really change things. So just give me the $50 after the show for the plug.
We took your home address down before we started.
That's one thing I'm thinking about. And then the other thing I'm thinking about is I'm a little concerned that with the Kubernetes obsession in the community. And I'm concerned that it's sort of being perceived as that silver bullet. And what's happening is a lot of people are making the awful approximation that somehow Kubernetes is the only way that one will deploy software, and that it's the only way that people will ever deploy software. And that's obviously not true. There are still, and probably will always be, workloads that belong on VMs. There's serverless, edge functions, all kinds of stuff. And the industry, we've got WASM going. We've got, eBPF going. We're always inventing new ways to build software. And what I find is that everything is so Kubernetes obsessed that it's creating this fork in all of our technologies. And anytime I go and read about a new project, oh, have you seen the guacamole framework? Oh, let me learn about guacamole. You click on it, and it's the greatest thing since sliced bread for, scaling your wiggle woms on Kubernetes. Everything is like for Kubernetes. And, it's like, hey, what about the rest of the world? The truth is that Kubernetes is complex. I'm not forecasting its downfall or anything like that. It's a great primitive, but it's not the only thing. And I'm concerned that it's making our life pretty complicated, and people are making some bad assumptions. Like the story of multi-cluster Kubernetes and having VMs talk to Kubernetes, talk to, Lambdas, and like that network connectivity story is so complicated, service meshes. And I just think there's a lot of incidental complexity there. And I don't claim to know what the answer is, but my spider sense says that we're going to be writing about this 5-10 years from now, just like we did about, remember the days we thought enterprise service buses were great things? Ha ha ha.
Having been on the front lines of this for a while, it is enormously complex, and it is a hindrance. It's a hindrance, and it's another kind of black box to some extent, where problems exist and people have a really difficult time troubleshooting them. And it's something I've talked about in a few other podcasts. I agree with you that it's one of those things that it's all the rage, but I'm not sold on whether it's the future for everything, as you just described, because
and the way that I look at it is I'm even putting that aside. Pretend you were sold for a second. It's simply impossible that it will be the only way that one deploys software. You would say to people like, you can run MySQL on Kubernetes. Why would you? One of its most foundational principles is that it wants services to be disposable. That's a great principle for what it was originally designed for. And, at Twilio, for example, we had stateful phone call connections that had to be up for up to 24 hours. Right. Like, can you imagine like that amount of state, it's facilitated via the SIP protocol and UDP and all kinds of jazz. But can you imagine trying to do that in Kubernetes? It just wouldn't make any sense. So even if you love Kubernetes, the idea that somehow it's the only way is it's silly.
Yeah, no, I agree with you. Well, listen, Joe, love the time together.
Likewise.
Thank you so much for joining us on the call. And I do think we're going to do a phase 2.
All right.
Part
Sounds
2.
good.
A lot of fun.
All right.
Thank you.
Yep.
Thanks for listening to the Big Ideas in App Architecture podcast. If you like what you hear and want to watch the episode, head over to our YouTube page linked in the description below. Also, be sure to rate the podcast 5 stars, and we'll talk to you next time. Thanks. Bye.